Here we're going to graph another parabola. So here in this parabola, A is 1, B is -2, C is 3. Just going to go through all our steps here. First, A is 1, which is bigger than 0, so it's up. 2, axis of symmetry. Remember, that's the x-coordinate of the vertex, which is going to be x equals -b over 2a, which is going to be 1. Vertex, x-coordinate is 1. The y-coordinate is going to be whatever I get when I plug 1 into my function, which is 2. So my vertex is the point 1, 2. My y-intercept, I'm just going to plug 0 into my function, and I'm going to get 3. So the y-intercept is going to be 0, 3. And then lastly, talk about x-intercept. So that's x squared minus 2x plus 3 is 0. You're going to try to factor this. So two numbers that multiply to -2 and add up to 3, that doesn't exist. So we're going to do the quadratic formula. So it's -b plus or minus the square root of b squared minus 4 times a times c, all over 2a, but a is 1. So this is going to be 2 plus or minus the square root, and then underneath the square root I have 4 minus 12, which is -8 over 2. So at this point I see that my solutions here, so this is, 2 plus or minus 2 root 2i. If you put root 8 in your calculator, you're going to get 2 root 2. And so, keep going. Okay, so these are my roots here, but it doesn't really matter because the point is that these are imaginary numbers or complex numbers. Okay, so I have complex roots here, so that means there are no x-intercepts. So whenever you are finding the x-intercepts of a quadratic function and you get imaginary solutions, you're going to have no x-intercepts. So my graph is not going to go through the x-axis. Okay, there are no points on the x-axis. But I can still sketch a graph of this because I have enough information. So my vertex is 1, 2, so that's right here. My axis of symmetry is x equals 1. My y-intercept is 0, 3. So I have a symmetric point on the other side here, so that's going to go here. And I would like to have more points here, so I'm going to go ahead and plot more. But I'm going to use, so you want to look at the points that you have and then pick x values that make sense. So it makes sense to plug in -1 and 3 because those are nearby. If you plug -1 into this function, then you're going to get 6. So I'm going to put that here and plot that. And I get another point for free because of symmetry. So this is 2 away from my axis of symmetry. There's going to be another point over here on the other side. So I can go ahead and plot that without even plugging anything in. I know that I'm going to get 6 there. So I just go ahead and plot my parabola. And there's our parabola. So that's what happens when you don't have any x-intercepts. In other words, when you have complex numbers as your solutions when you try to find the x-intercepts.